All right, good morning everyone, or afternoon whenever you're watching this. Make sure that you have a PDF form of this and you're taking notes along with me, and then you're going to upload that to Canvas so I can see that you have done it. All right, let's get started. So over on this side are all the formulas that you're going to need and what the things stand for. And then we have a question for each one, except for I don't have a circle on here. I don't know why. The circle's just an ellipse, just with the same distance in each direction. All right, so here we go. We have a parabola. We can tell this is a parabola right away just by looking at it, because it only has one squared term here. The x is squared, not the y. And so let's start with the vertex. And the vertex for this parabola is -2, +1. It's always the opposites. And so go over here and plot -2, +1. And if I can get that a little bit better, there we go. Okay, and now we're going to find the focus point. So if you look over here, the focal length is p. That's the distance from the vertex to the focus is p. And in our formula, this number is 4p. So if we go over here, -4 is equal to 4p. So right away we could see that p is -1, which means that we need to go 1 down from the vertex, because this parabola, I forgot to mention that, the x is squared, excuse me, the x is squared, which means our parabola is going to open up or down. And then this is a negative, so we know for sure that our parabola is opening down. So then if we're going to go down 1 for the focus, our focus would be right there, and that is at the point -2, 0. And our directrix would go in the exact opposite direction, 1 up from that. So our directrix is y equals, don't forget it's either x equals or y equals. In this case it's a horizontal line. Y equals 2. Now to graph this thing correctly, okay, because that's important too, we know that the focal width is 4p. So our focal width is -4, well, it's the absolute value of -4, so it's 4. So I would go 2 in each direction for a total width of 4. It's a focal width. So here's the focus, and 2 in each direction make a total focal length of 4. And then you could draw your parabola. Okay, so let's get back to this. Sorry, I had to take a little pause. The next problem is an ellipse. And so all the formulas are given over here at the side. Let's go ahead and start by finding the center. So the center would be +3, -1. So we'd go over here to +3, -1, and that's the center of our ellipse. To graph this thing, I'm going to graph it before I find the foci and vertices. To graph it, a squared is 36 and b squared is 16. So I need to take the square root of 36, which is 6. Now, I didn't plan this very well, so I'm going to go 6 in that direction, and 1, 2, 3, 4, 5, 6 in that direction. And then we're going to go up and down a distance of 4. 1, 2, 3, 4. And 1, 2, 3, 4. Got an angry kid stomping away. I'm going to check it out. So BRB. All right, so now we have the foci. We have to find the foci. And remember, foci is always, it's right over here. C is the distance from the center to the foci. So we're going to use actually this formula, a squared minus b squared, always the big number minus the small number. So 36 minus 16. So C would give us plus or minus rad 20. Make sure you rationalize. That's plus or minus 2 rad 5. Now remember, foci, those are points on our, not on the actual ellipse, but they're points that are found here, and they're always on the major axis. The major axis is always the longer axis. In that case, it's going horizontally. So we need to add or subtract 2 rad 5 to the center, but to our x value to get out to the foci, which are going to be on the inside of the ellipse. So 3 plus or minus 2 rad 5, -1. You can leave it just like that. It's perfect. And then our vertices, of course, are always on the longest axis. And like we said, the longest axis here would be going left and right. So basically, to find the vertices, you're going to take the center, which is at 3, -1, and then you're going to add or subtract 6, because that's how far we went in each direction. So if those are nice numbers, I'd like you to go ahead and write that as 9, -1, and -3, -1. All right, there we go, moving along. Next one's up is a hyperbola. Now remember, hyperbola is all about which variable comes first. In this case, the y is first. So make sure you're very careful with finding the center. I'll have a lot of people who will say the center is -1, 3, but in fact it's 3, -1, because it's always x first and then y. So we go over here to 3, -1, and we want to go up 3, 1, 2, 3, and down 3, 1, 2, 3. Those are our vertices. Okay, I could go ahead and label them right here. So that's 3, 2, and 3, -4. So those are our vertices. And then don't forget, the way that you graph a hyperbola is you're going to go square root of 1 in each direction. And this is going to look really ugly, I can tell already. But you're going to draw a box here, or a rectangle, I guess, not really a box. And then don't forget your asymptotes. Don't draw them too thick. Nobody likes a thick asymptote. All right, and then there you go. And there's your hyperbola. Beautiful. Hopefully yours is nicer. Foci, c² equals, and it's plus in the middle, okay? The hyperbola has a minus in the middle, but the foci has a plus in the middle. So c would be plus or minus rad 10. And then from the center, that would be up and down a distance of rad 10. So the 3 will stay the same, but this will be -1 plus or minus rad 10. And then the asymptote equations, which of course I didn't give myself enough room. The asymptote equations are kind of cool because it's just the point slope form. Y minus k equals plus or minus rise over run x minus h. And y minus k is right there, and x minus h is right there without the squared. So we're going to write y plus 1 equals plus or minus, because there's 2 of them. There's 2 asymptotes here. The rise on the asymptote was 3 and the run was 1. So you could write 3 over 1 or just 3. And then x minus h was x minus 3. X minus 3. And those are your asymptote equations. All right. All right, so here we go. We need to rewrite in standard hyperbola form, which means that we are going to complete the square twice now. Okay, so what I'm going to do is I want to get the x's together, so 5x² minus 20x, and then we'll get the y's together, minus 4y² minus 16y, and then add the 16 over to the other side. So we're ready to factor out a 5 here, leaving us with x² minus 4x plus blank. Leave yourself a blank. And then we need to factor out a -4 here, which leaves us with y² plus 4y plus blank equals 16. Now, take half of -4, which is 2, square that number, and you get 4. But we're going to add 20 over here. And then this is a -4, remember, and we take half of this 4, squared is 4, and we're going to subtract 16, because this is a -16 that we've added to that side. It's the only time you subtract a number over there. So now we have 5x minus 2 squared minus 4y plus 2 squared equals 20. And then we need to get a 1 over here, so divide everybody by 20. And so our final answer should be x minus 2 squared over, and 5 over 20 reduces to 4, 1/4, and then minus y plus 2 squared over 5 equals 1. So there it is. And it didn't ask you to find anything else. It didn't ask you to find any of the parts or anything. So we can just leave it. All right, so the next one is find the equation of the parabola. Whenever I'm asked to find an equation of these things, when I'm given certain parts of it, I like to draw a picture to see which way it's going to go. So the focus is at -2, +1. Label that as a focus. And the directrix is over here at x equals 2, so it's a vertical line. All right, that tells me that this parabola is going to have a vertex in the middle between these two things. And so that middle would be right there. So the vertex would be at 0, 1. It also tells me that this parabola is opening to the left. Now, if our parabola is open to the left, then that means that we have to use the formula y minus k squared equals 4p x minus h. All right, so let's find out what all of these things are. Well, we already know what h and k are, but what's p going to be? Or 4p, I guess. So p is, remember, the distance from the vertex to the focus, and I like to put that as a distance of -2. All right, so now I'm ready to put all the information into this problem. So we have y minus 1 squared, so don't forget that comes from the vertex, and that's the k value is 1, equals -8, and you can write x minus 0, but you could also just write x, and that would be fine. All right, a couple more. Number 6, we need to find the equation of the ellipse with the vertices and the minor axis. They actually give you everything on this one. This one's not too bad. So let's go ahead and find out what our ellipse would look like. So we'd go -4, +5, 1, 2, 3, 4, 5, and -4, -3. All right, and the minor axis has a length of 3. And so it's going to look, length of 6, which is 3 in each direction. All right, so let's go ahead and find our center. It's in here somewhere. So our center is going to be at -4 something. Now I kind of like to look at 5 and -3, and that's a total distance of 8, which means up and down would be a direction of 4. Half of 8 is 4. And so if I were going to come down from this vertice, which is at -4, 5, then my center would be at -4, 1. If I was going to come up 4 from -3, I would land at 1 also. And then A, which is our left and right distance, is a total of 6, which means A would be 3. So we have all of our pieces, we're ready to go. Now remember, with an ellipse, we always just put x first. So we're going to go x plus 4 squared over a squared, which is 9, plus y minus 1 squared over 16 equals 1. There we go. Now it doesn't matter if you had these switched, that would be fine too. Usually just x goes first for hyperbolas, for ellipses. But hyperbolas, it matters which one goes first because it's minus in the middle. All right, so this one's a little trickier. Let's go ahead, and we have -1, +3. That's a vertice. And then we have -1, -1. That's another vertice. So we know that this hyperbola looks like that. All right, so let's talk about where the center is first. So that is a distance of 4. 3 to -1 is 4, which means if I went up 2, or, wait, is that up 2? 1, 2, or I was up here at 3 and I went down 2. Did I graph that wrong? No, it should be like right there. Okay. Then that means that my center would be at -1, +1. So that's my center. Okay. So let's take a look at also, we can tell what B is, because since this is a total distance of 4, then B would be 2. Now let's look at, we are given foci. So we don't know how far left and right. We don't know what A is, but we do know that our foci are here and here at -1, 4 and -1, -2. And that, if you count that off, that is a distance of 3. Okay, so that means that C is 3. And we know that C squared equals A squared plus B squared for hyperbolas. So 9 equals A squared plus 4. So A squared would be 5. And there's no need to take the square root of that, because now we're going to write our equation. I'm going to write it over here. Okay. So y is going to be first because it's going up and down, and don't forget this is hk, and k is the y value here. So we have y minus 1 squared over b squared, which is 4, minus x plus 1 squared over a squared was 5, and this equals 1. So there it is. Okay, so now for these, you just have to identify. Okay, this is a really good multiple choice type of question because there's 4 answers here, and all you need to do is look at the squared terms. You can ignore the rest of it. As long as they're all on the same side, look here, and our squared terms have a minus in the middle, so that would be a hyperbola. Over here, these have 2 squared terms with a plus in the middle, and our coefficients are different numbers, so that would be an ellipse, because the ellipse is plus in the middle, but the ellipse goes, different lengths up and down and side to side. This one has 1 squared term, so that would be a parabola. And then this one has both of the numbers are the same, and there's a plus in between them, so that would be a circle. All right, here's our last one. Given the parametric equation, we can graph this. Now, it says eliminate the parameter and find the corresponding rectangular equation. So you can, if you want to, graph this in parametric form on your calculator, but we're going to have to find a rectangular equation anyways, so I'm going to hold off on actually graphing it on my calculator. Now, to solve, let me get rid of some of that right there. To actually solve this or get this into a rectangular equation, you should do is solve for cosine and solve for sine. So we're going to add 2 over to the other side and divide by 2, and that's equal to cosine of t. And then for sine, let's go ahead and we will add 1, divide by 4, and you get sine of t. All right, now take each of those and square them, and here's where the magic happens. We get cosine squared t equals x plus 2 squared over 4. So squaring everything. You square that, and then square this whole thing too. So we get sine squared t equals y plus 1 squared, over 16. And then if you add these up together, cosine squared plus sine squared, as you know, is 1, and then you can add up the other side. And so this is what it would look like. X plus 2 squared over 4 plus y plus 1 squared over 16 equals 1. And you can recognize that is an ellipse. And so the center of that ellipse is -2, -1. So we'll go over here and we'll graph -2, -1. And the vertices, of course, are going to be to add or subtract 4. The vertices are at the farthest away, so we're going to add or subtract 4 to the y value. So that would be at -2, 3, and -2, -5. And you can plot those by going up and down a distance of 4. Okay, and then finally you'd go left and right a distance of 2. Distance of 2, and there you, nope, still no. Well, still definitely no. All right, and there's your ellipse. Finally, the foci, c squared equals big number minus small number, which will give me plus or minus rad 12, which is 2 rad 3. And then from the center, up and down, because that's our major axis, we're going to go from the center, not from the vertices, -2, -1, plus or minus 2 rad 3. There we go. All right. Good luck on the test, you guys. You got this.